Hello and welcome. So this is a continuation of managing large dataset of tasks, part 2. So on our part 1 of this series, we talked about the notifying all we talked about notifying all users. So in our example was notifying all the million users using the combination of inner map and task async. And also we saw how we can notify all the users using the combination of inner map and task start. So with the task.start, an error was displayed. So this error was notifying us of too many processes being started, and also we saw a system limit error, which was informing us of a system limit that has been reached. So this is a limit on how many processes can be concurrently started in the beam, and there's always a default value. So the default value is approximately 200,000 and something. And also we saw the same behavior with the task to start, that only approximately 200,000 messages were being sent to the given numbers, while the rest of the numbers were being ignored. So with the task async, unlike the task async, we were able to start the 1 million processes, but this 1 million processes were being started at the same time. So the million processes, yes, it's too many, and this can cause sudden pressure on our system and also make the system unresponsive, or also cause a spike in other third-party resources. So how can we leverage concurrency when managing series of tasks using the task function? So the task module has another function, which is the async stream, works similar to the combination of inner map and task async. It starts a process, then performs the task for each item in the list concurrently. So the only difference between the async stream and the combination of inner map and task async is that with the async stream, you can set a limit on the number of processes that are running at the same time. So for example, we saw with the task async, all the million processes were being started at the same time. So with the async stream, we can set this concurrency limit. Let's say we want only 100 messages to be sent at a given time. So with the option of max concurrency in async stream, you can set this limit to 100. So that means it will start 100 processes at the same time. So the messages will be sent in a bunch of 100 till the 1 million processes have been sent. So what is the advantage of the async stream over the combination of inner map and task async? So one is that we can easily handle the back pressure. So the back pressure is where a software usually takes in an input and turns the input into a desired output. But with the back pressure, the progress of turning this input to an output is usually resisted. So for example, we want to process 1 million messages. So having 1 million messages as an input, we have a million numbers being taken in, but with these million numbers, with the task async, we start 1 million processes. So all these processes will occupy space in the memory, and this might cause the system to respond slowly. So that means it will take some time to process these messages, and it might also cause a delay. So that is one example of a back pressure. We can give also a back pressure, an example with a real world situation. So let's say we have a water pipe. Water pipe is connected from source A to the consumers. If this water pipe flows safely from source A to the consumers, that means the flow that means the water been conveyed well. But if we decide to introduce a block inside the pipe, it means that the water will flow through the pipe from source A swiftly, but when it reaches this block, it will prevent that flow from reaching the consumer. So there will be a force opposing that flow. So there will be no desired flow, unlike when we don't have the block inside that the water pipe. Another advantage is that it prevents sudden spike of the system usage. So with 1 million processes being started at the same time, this 1 million will will consume a lot of memory in our system. So unlike where we start, we unlike with a sync stream, we have limit on the number of processes being set. We can set a limit on the number of processes being started, and even if we don't set that limit, it will use the default limit of our system. For example, mine, if I don't set the limit, it will be sending it will be starting 10 messages at the it will be starting 10 processes at the same time. So with that, we can prevent a spike of our system usage. So how does the async stream work? So it usually takes in an enumerable, then start a process and perform a task for each of the item given. Then in return, it returns a stream. So a stream elixir is usually a stream elixir is a lazy enumerable that don't apply transformation to the enumerables given immediately, but only when explicitly told to. So we can look at an example of how a stream works so that you can understand what I mean by not applying transformation immediately. So I'll just clear this first. That my interactive shell is in the mix command. Okay, so I want to have a stream function. So for example, let's say we have a list of numbers, and this list of numbers is 1, 2, 3. So I want to add each of the item to increase each of the item in the list by 1. So with the enum.map, for example, when you give it a list of numbers, it takes an anonymous function, and we increase each of the number by 1. We immediately expect the result. So we have 2, 3, 4. Let's do that with the stream.map. Takes in a list. Let's increase the numbers. We get this. Just a minute. I fix this. Send the call. Okay. So with the stream functions, we get a stream as the result. So this stream has an intent of what was meant to be done, and we can only get the desired output once we decide on applying the transformation on this list. So with this, by transforming this into a desired output, or if you want to use that output in a different way, you can transform it using the enum functions. So here we'll call the toList enum function, and I'll get the output that I may want. Okay, so similar to how the stream function works, the async stream also return a stream. Let's see at an example of how async stream work. So with the task async, let's give it the list 1, 2, 3. Takes in that function, then applies the task the task on each of the item given concurrently. So it returns a stream, and we can only get the desired, we can only transform this using the enum functions. So I'll call the toList function again. And we see we have a list of tuple, okay, and the number that we have increased in each of the lists, that we defined above. So that's how the async stream works. So also it takes in an option. It takes an option that can be used to control the level of concurrency, the time tasks are allowed to run, and also the ordering of the result. So we shall explore more of the option, how they work, in the next in the part 3 of the managing series of tasks. Well, welcome and thank you for watching this.